This is the remainder theorem. Tonight's homework is page 457. We're going to do numbers 17 through 24. I do want to remind you that our power is closed on Wednesday. It's Halloween and it's always low attendance. So our power is closed. So that means those of you who are trying to do the retake on Thursday, you remember that you do need your 2 hours before Thursday. So if you're counting on Wednesday, don't count on it because it's closed. So you're going to have to come after school tomorrow and maybe before school on Wednesday. Or tomorrow before school. Wednesday before school is going to be real hard because we have a faculty meeting. So I wouldn't count on that either. Thursday before school, maybe, but that's it. All right. Number 33 from the review assignment. It's asking me for the vertex and axis of symmetry. Y equals 1/4 x minus 5 x plus 2. They're asking me for basically the same thing, the vertex and the axis of symmetry. I need two things, b and a. That's basically what I need, negative b over 2a. Well, my a is right here. I already know what my a is. Do I know what my b is? Don't yell it out. Do I know what my b is in this equation? Raise your hand if you can tell me what the b is in root form. What is the b in root form? Raise your hand if you can tell me. Which form has b in it? Standard form. Is this standard form? No. So what I'm going to have to do is FOIL it out and get my b. Okay? There's a lot of side to chat. We need to stop, please. Thanks, Ben. So let's FOIL this out. So this is going to be x squared. We have negative 5 and a 3. That's minus 3x. And then multiply. That's minus 10. And then we're going to multiply that by 4. 1/4, excuse me. So again, it ends up being 1/4 x squared minus 3/4 x minus 10 over 4. So now I have my a and my b. I already knew my a because I had it from the beginning, and now here's my b. So negative b over 2a is negative 3/4 over 2 times 1/4. So for those of you who don't like fractions, you could just pretend that this is a quarter and this is 3/4, which is like 75 cents. So what's 2 times a quarter? 50 cents. So those of you who like decimals, you would change this to a 0.5, which is fine. Or if you like the fraction, you can keep it as a fraction as 1/2, whichever you prefer. And then this is like 75 cents negative. So negative 75 cents, this would become a what? Positive. So those of you who like decimals, you would put 0.75. And those of you who like fractions, you would keep this as 3/4. So on your calculators, please, don't yell it out. What is 0.75 divided by 0.5? Or what is 3/4 divided by 1? Lauren? Where's your calculator, babe? Jarrell, what'd you get? 1.5? Or 3/2 if you like fractions. So your axis of symmetry, so far, you know your axis of symmetry is x equals 1.5 or x equals 3/2. This is so far your axis of symmetry. Dylan, how do I get the vertex if I know my axis of symmetry?
I just put
just plug it in. Very good. Would you prefer to plug it into standard form or into factored form? Standard? Okay. I don't know. I kind of like factored form. You guys know why? Because if you plug in 1.5 right here, you just get like a number times a number instead of having to square a fraction, which you guys often make mistakes on. I don't know. I much prefer standard form. But if you like, I'm sorry, factored form. If you like standard form, you just have to remember when you square it, because some of you guys, when you plug in a negative in here, you mess it up. And then when you subtract a fraction that's a negative, you mess that up too. So I'm not saying like you can't do it. What I'm saying is I'm seeing your flaws, and you guys make less mistakes when you use factored form. That's this class specifically. Because look, take this 1.5. What's 1.5 minus 5? Negative 3.5. What's 1.5 times plus 2? 3.5. It's not a coincidence. It's always going to be like this. The vertex has to be right in between, so these are going to be exactly the same and opposite. It's going to happen every time. And then what do you do with that? Multiply it by 1/4. So I just feel like you make less mistakes when you do this times 0.25, which is 1/4. Instead of this. Because there's no 10 necessary. You don't have to multiply by 3. You just. So what's the final answer? What is negative 3.5 times 3.5 times 2.5? I'm sorry, 0.25. Why are you guys staring at me because I'm cute? Can you just put in your calculator, please? 3.5 times negative 3.5 times 0.25. Alyssa, what do you get? 3.6? Is that what y'all got? Negative. It should be negative, yeah. Try it again, son. Negative 3.5. Negative 3.5. 3.16. That's what you got. Okay. 0.6? 0.16 or 1.06? Okay, let me write it down. Ready? Your vertex should be at 1.5, comma. Yes. And that is your vertex. Can you show me tonight's homework copy form? Did you take a picture? Did you take a picture of tonight's homework? No. Can you show it to me after the session? Because it looks like it's different from what I have. All right. We're going to go over some more factoring, and then we'll go over some notes. So this is example 1. Sum or difference of cubes. Mia, can you remind me what the sum? What is the word definition of sum again? What happens when you do something to two numbers and it's the sum? What did you do to two numbers? Multiply? What's multiply again? Product. Do you remember what sum and difference are? What's sum, guys? Adding, and difference is? Very good. All right, so this is the sum and the difference. So I want in big highlighted letters, I want you to put sum and difference. Not product or quotient. It's only for adding and subtracting. Cubes. Do you guys know how to draw a cube? Watch how I do this. I'm not the artist, but I know how to draw a cube. A square overlaying a square, and then you connect. That's a cube. You guys see how I did that? Do it again. Ready? Square overlap a square, then connect. One more time. A square, overlap a square, and then connect. Draw it twice or 3 times so you know how to draw a cube. My artists in here are cringing. She didn't dot the lines. I know. But you can see the cube. Pearson, are you with me, sweetheart?
Yeah, no, I didn't know how to draw cubes.
All right, cool. So, if I'm adding or subtracting cubes, what do you know about all the sides of a cube, Heidi? They all have to be the same. Very good. So a cube would be like 2, 2, and 2, or 3, 3, and 3, or 5, 5, and 5, or 1.5. They're allowed to be fractions and decimals as long as they're all the what? The same. So what we're doing is we're adding and subtracting these. I'm giving you a visual of what we're doing. Isaiah, I need you good. So this right here is how to add and subtract different cubes. So example 1, let's say I want to do x cubed plus 125, and I want to factor that. Well, this cube, what are the side lengths of this cube right here? It would be right, x times x times x. Because isn't x times x times x x cubed? What would be the side lengths of this cube? Do you guys know how to do this on your calculator? Ready? Let's do it together. Find this button on your calculator. Those of you with graphing calculators, it's under the math button. And it's the cube root of 125. That's going to tell me what times what gives me 125. What is that? 5. So this is 5, 5, and 5. God bless you. God bless you. Now, because it falls under the criteria of being a sum and a difference of cubes, now I'm allowed to use the formula. What do all my rookies do? For the last 10 years of teaching, they want to use what I'm about to show you for anything. Can't do that. It only works if it falls under the criteria. It has to be a sum and a difference. There you go, sum. And it has to be 2 cubes. And it has to be 2 cubes. Mia, are you with me, sweetheart? All right, now you can use what I'm about to show you. All right, here we go. This is the formula for the sum and difference of cubes. Please, please have it stand out of your sheet. It needs to stand out. You're not going to memorize it any other way. If you have the sum of cubes, which can be written as a cubed plus b cubed, or the difference of cubes can be written as a cubed minus b cubed. Where'd these letters come from? A represents the x here, and b would be your 5. So whatever this first part is a, and whatever the second part is b. This case, we're doing a sum. If it were a difference, you would use this one, okay? And the fastest way to do this is not make it harder than it needs to be. All you have to do is plug and chug into this formula. A plus b, a squared, minus ab plus b squared. That's if it's a plus, and if it's a minus, it's a minus b, a squared plus ab plus b squared. Now in this scenario, for example 1, are we going to use the sum of cubes or the difference of cubes? We're going to use a sum. Why? Because it's plus, so I don't even care about this one. I'm not going to use the bottom one. I'm going to use the top one. In example 1, very simply, A is x because x times x times x is x cubed, and B is 5. All I have to do is everywhere I see an A, I'm going to put x. Everywhere I see a B, I'm going to put in, everybody with me, everywhere I see an A, I'm going to plug in x. Everywhere I see a B, I'm going to plug in. That's it. Please don't make it harder than that. I'm giving you the formula. I'm just telling you what to plug in. Pretty easy? Yes or no? Watch. Everywhere I see an A here, I'm going to plug in x. So boop, boop, boop. Everywhere I see a B, I'm going to plug in 5. Boop, boop, boop. And then I'm done. I have now factored this binomial. Easy? All right, so watch. My answer to this is going to be, if I want to factor x cubed plus 125, let me box it up so you can see. I'm going to use this formula right here. A is x, B is 5. So I'm going to write x plus 5. A is x, so that becomes an x squared, minus them 2, so that's 5x, and then plus b squared, which is 25. Let's try another one. Yes, honey? No. This right here, you guys, that I'm going to do in green, this is your answer. Right here. That's your answer. This is the formula to get to your answer. That's it. Let's try another one. Example 2. And then I'm going to teach you an easy way to memorize it. Please factor 8x cubed minus 27. Is this a sum or difference of cubes? Let's check. What is A for 8x cubed? What is the length of each side of the cube? 2 what? X. Good. So 2x times 2x times 2x. Isn't 2x times 2x times 2x? Isn't that 8x cubed? It's not 6, is it? What's 2 times 2 times 2? 8, not 6. Right? How about this cube right here? What are the dimensions of the cube if I get a 27? 3. Don't say negative, because this is a difference of 2 cubes. So ignore that. You're still doing the cube. Can't have a negative length. Right? Can't have a cube that has a length of -3. That makes no sense. All right, so what's your A then? A is 2x. What's your B? 3. And it's a difference of cubes. So that means I'm going to use the A cubed minus B cubed, and that's going to be A minus B, A squared plus AB plus B squared. Now everywhere I see an A, what am I going to plug in? 2x. Be careful. Everywhere I see a B, what am I going to plug in? 3. Nicely done. So 8x cubed minus 27 is going to factor to All right, Deshaun, tell me what to write, sweetheart. Good. Which is, what is 2x times 2x? Perfect. Mm-hmm. Which is? Yep. Which is? Nice. That's it, guys. That's all she wrote. Y'all ready for a doyo, or should I do one more? You ready? All right, here's your doyo. Please factor 125 m cubed plus 8. Kathleen, what's your A here? Good. And what's your B? 2. Are we using the sum or difference? All right, so let me teach you the trick on how to remember. Please remember the acronym SOAP. SOAP stands for same, opposite, and then always positive. So what that means is the first binomial is the same sign. The second one, the second sign is the opposite, and the last one is always positive. Let me show you what that means. I'll go back to that. So if this is a plus sign, same, opposite, always positive. This is the same sign. This is the opposite sign. This one is always, no matter what, positive. That's how you can remember what the signs are supposed to be in between each one. I'll say that one more time. This is a sum of cubes, so since the actual problem had a plus, the first binomial is going to have a plus. Same. This is opposite, and the last one's always positive. And that's how you can remember in which order to write your signs. Same, opposite, always positive. All right, Mina, what did you get for your final answer, honey?
5m plus 2 minus 25m squared minus 10m plus 4.
Questions on the doyo? All right. Example 3. We're going to move on from factoring and take a look at what you're going to be seeing on tonight's homework. Okay, wake it up. You're going to be given something like this on your quiz tomorrow. Is x plus 2, thank you, a factor of 2x cubed minus 7x squared minus 10x plus 24? Is 6 a factor of 12? I know you guys are still copying this down. Is 6 a factor of 12? Yes, why? Is there a remainder? No. Is 5 a factor of 12? Why not? Because there's a remainder. Is 12 a factor of 24? Why? Because there's no remainder. Caesar, this is when I need you the most. Is 10 a factor of 100? Why? Because there's no remainder. Is 10 a factor of 15? Why not? Because there is a remainder. Is x plus 2 a factor of this polynomial? How can I find out? Divide it and see if there's a remainder. There's 2 ways to divide. We had 2 ways last week. You pick which way you prefer. Long division or synthetic division? Let's do it synthetically first. So I'm going to have a negative 2 in the corner. 2, negative 7, negative 10, and 24. Let's drop it like it's hot. And then multiply, add, multiply, add, multiply, add. 2 times negative 2, that's negative 4. Add these up, that's a negative 11. Negative 11 times a negative 2, that's positive 22. Add these up, you get 12. 12 times negative 2 is negative 24 for a remainder of 0. Is x plus 2 a factor of this polynomial?
Yes.
Why? Because there's no remainder. This is going to be on your quiz tomorrow. I'm going to ask you to tell me if something is a factor, and you just have to explain why it is or why it is not. Here's your doyo. Is x minus 1 a factor of 7x cubed minus x plus 12? Do you see what's missing? Okay, don't fall for it. Make sure you include it. Did you guys, everybody get a 6? 16? What'd y'all get? 18? I think it's 18. So you should have put a 1 here, right? 7, 0, negative 1, 12. Don't forget to drop it. 7, 7, that's a 6, that's 18. All right, on tonight's homework, you're going to be given something like this. You can even put it's number 19 on tonight's homework so you know how to do it. You're going to do them all the same way. We're going to see if x plus 3 is a factor of x cubed plus 9x squared plus ax plus 15. So they're literally not giving me one of these terms. No problem. What I'm going to do is I'm going to take this guy that I had upstairs, and instead of doing synthetic division, I'm going to plug him in to the x. So what I'm going to do is I'm going to get negative 3 cubed plus, excuse me, 9 times negative 3 plus a times negative 3 plus 15. Negative 3 cubed is 27 plus negative 3 squared, that's 9. 9 times 9 is 81. Thank you. Minus 3a plus 15. All I'm going to do now is add these bad boys up, combine them. Negative 3 times negative 3 times negative 3 is a negative 27. Negative 3 squared is a positive 9. 9 times 9 is 81. Negative 3 times a is just negative 3a. This is an a. This is what we're trying to find. Guys, I'm running out of time, so I need you. Negative 27 plus 81 plus a 15, that ends up being 69. So in order for me to find a, I don't want a remainder, so all I have to do, you guys, real simple, is set this equal to 0 and solve for a. So 69 minus 3a equals 0. Negative 3a equals negative 69. So a is equal to 23. So if I plug this back in, my final answer is going to be x cubed plus 9x squared plus 23x plus 15. Can you guys do number 20 with your group? So I know you know how to do it. Pull it up on your Google Classroom.